Welcome to this explainer. Look, between the relentless corporate hype on one side and the constant doom-mongering on the other, it is incredibly hard to know what is actually going on inside the AI tools we keep hearing about. So today, we're cutting right through all of that noise. We're popping the hood to see the actual mechanics of what makes these things tick. Our main goal today is to build one unshakable, foundational mental model of what a large language model actually is. Whether you're actively using ChatGPT, Claude, Gemini, or any of the others, everything about how you use them and, frankly, how you protect yourself from their mistakes completely depends on getting this right. And honestly, the best way to understand what this technology is to start by deconstructing what it definitely isn't. First off, we have to totally throw out this science fiction idea that there's some little digital consciousness living inside your computer. It is not a brain, and it is definitely not a mind. It's not thinking thoughts, it doesn't have goals, and it literally has zero feelings. It produces text that looks like it came from a thinking being simply because it was trained on text written by actual thinking beings. Second, it is not Google. People constantly assume that when you ask an AI a question, it goes out, looks up the correct information in some giant database of truth, and simply reads it back to you. And hey, it feels perfectly reasonable to assume that, but it's entirely wrong. When a base language model answers you, it is absolutely not looking anything up. It's doing something entirely different. And third, it is absolutely not magic. The core concept behind how this all works is genuinely simple. Seriously, you do not need a computer science degree to grasp this. You can totally understand it right now. Just look at the comparison here, because it brilliantly illustrates the utter absurdity of the AI is a brain myth. Think about it. A human brain runs on roughly 20 watts of power. That is basically a dim light bulb. And a child? They can learn a new word from seeing just one or two examples. But in AI, it needs massive, sprawling data centers and an industrial slice of a power grid just to run. It has to chew through a meaningful fraction of literally everything humanity has ever written just to learn how to talk convincingly. They are doing fundamentally different things. So here is the crucial takeaway. A large language model is simply a pattern machine. At its absolute core, it is essentially an extraordinarily sophisticated version of the autocomplete on your phone. You give it some text, and it statistically predicts the most likely next chunk of text. And then it does it again and again, predicting its way through a situation literally one single word at a time. Sure, it absorbed huge amounts of text to be able to do this, but prediction is the entire engine running the show. To make this a bit more concrete, I want you to picture a bartender. But not just any bartender. Imagine a bartender who has never had a single original thought in their entire life, but who has somehow read a meaningful slice of everything humanity has ever written. We're talking every novel, every dense legal textbook, every recipe, every random online argument, and every single line of computer code. Now, they didn't memorize it word for word, but they totally absorbed the patterns of how all those words fit together. So imagine you sit at the bar and ask this bartender, "Hey, can you explain quantum physics to me like I'm 5?" The bartender doesn't actually understand quantum physics at all. But because they've seen 10,000 examples of complex ideas being explained simply, they can instantly produce the familiar shape of a custom-fit explanation. They know exactly what that kind of explanation sounds like, and they just predict the words that fill that shape. It is all pattern, not understanding. It's prediction, not knowledge. Okay, moving into part 1, how it got this way. Let's look at training the pattern machine. So, how do you actually build this well-read bartender? Well, there are 4 major steps. First, developers essentially feed it the written world, an enormous body of text, scraped from the public internet and books. Second, they force the machine to play a massive game of fill-in-the-blank. The system is shown text with pieces hidden, and it guesses what comes next. If it's wrong, it gets corrected. And it does this billions upon billions of times. Third, through all that endless guessing, its billions of internal numbers, which are called parameters, get nudged and tuned until the patterns of human language are baked right in. And finally, humans step in for a polishing phase to help shape the models so it actually follows instructions and avoids spitting out obvious garbage. Right, on to part 2, the hallucination problem, or why it makes stuff up. This brings us to one of the most frustrating things about AI, the hallucination. This is when the model produces completely false or fabricated content, but does so with absolute, fluent confidence. When it invents a fake statistic, or a study that literally doesn't exist, or a quote nobody ever said, people almost always assume the machine is glitching or maybe deliberately lying to you. But actually, it's doing neither. It is doing exactly what it always does, generating the plausible shape of a correct answer. A fake citation has the exact same pattern and shape as a real one. Because it isn't checking a factual database, sometimes the shape it predicts just happens to be completely fabricated. Because of this, the absolute best way to frame your relationship with AI is to treat its output like a first draft from a brilliant, super fast, but slightly unreliable intern. It can save you hours of work, for sure, but you must verify absolutely anything that actually matters. This isn't just a bug you can fix by scolding the machine. It's a fundamental reality of how next word prediction works. That leads us perfectly into part 3, the practical payoff, what it's actually good and bad at. Now that we really understand it's a pattern predictor, we know exactly where it shines and where it will completely burn you in real life. It is amazing for drafting emails, brainstorming when you're stuck, explaining tough concepts, translating styles, and even coding, as long as you review it, of course. But on the flip side, it is incredibly weak and honestly risky when factual precision is required. Do not use these tools for citing specific numbers, real-time knowledge, or math unless you have a human actively checking the work. As a general rule of thumb, it's a phenomenal first draft engine, but it is a terrible final authority. And finally, part 4, the stakes, why this mental model matters. Understanding this pattern, not knowledge framework isn't just an academic exercise. It has serious daily consequences for how you use this tech. First, it explains the lying, which stops you from trusting it blindly and protects you from publicly repeating a made-up fact. Second, it guides you to the right tasks, saving you from a hallucinated disaster in a high-stakes business meeting. And maybe most importantly, it inoculates you against the endless corporate noise. When a CEO gets up and implies their new model is somehow conscious, you'll know that is just the stock price talking, not the technology. Autocomplete doesn't want anything. Remembering that keeps you grounded in reality. Well, we've covered a lot today about how this sophisticated prediction machine works, but I want to leave you with one bizarre, fascinating mystery for our next explainer. If this thing is so incredibly good at language, why does it completely fail when you ask it to count the letters in a simple word, like counting the letter R's in the word strawberry? The answer reveals exactly how these models actually see language, and I promise you it will completely change how you talk to them. We'll crack that open next time. Thanks so much for joining me.